The objective of this video is to show students how we can construct a hyperbola when two of its foci are given, and the difference between the two distances from the foci of the variable point which generates the hyperbola. We know the definition of the hyperbola is that it is the locus of a point which moves such that the difference of its distances from two fixed points, which are called foci of the parabola, is always constant. Consequently, we take up 2 points as these two. Let us label these points as A and another point as B. We join them by segment. Now these two things are given together with, we are also given the difference between distances of the variable point from these two fixed points. So let's suppose that distance is given to be this. So what we do is we draw a circle with center A and this as its radius. We draw a circle, we construct this circle. From this circle we take any point, any variable point, and from this variable point let us label this point as point C. We join AC by a line. Also we join BC by a segment. Now we bisect BC at its middle point. Let's label this point as D. To this segment BC, we draw a right bisector. That means a perpendicular line through its middle point. So we draw that perpendicular line. This perpendicular to BC and this line AC meet at a particular point, which we can highlight here. Let's suppose this is the point where they meet. We label this point as point E. Consequently, we find here that AE minus EC is equal to AC. Now E lies on the right bisector of BC, therefore EC is equal to EB. Let us join EB by this segment. EB is clearly equal to AC. Therefore, we can very easily say that AC is the difference of distances of E from A and B, the two foci. Clearly, the locus of E should be a hyperbola because the difference of the difference of distances of E from A and B is equal to AC, which always remains constant whenever we revolve C around this circle. Therefore, what we do is we highlight E and find its intersection, subject to the condition that we move this point C round this circle. We get a beautiful hyperbola whose foci are at A and B, and the difference of distances is the radius of this circle. That constructs the hyperbola.